This video is presented to you by www.testprepadda.com. Dear students, this is exercise number 8 of General Organic Chemistry. The questions of this exercise are based upon lesson numbers 27 to 33. So I request you all to watch those videos before attempting the questions of this exercise. This exercise has 5 questions. First, I will show you all 5 questions. Then I will explain you question number 1 and 2. In the same manner, remaining questions can be solved. I request you all to attempt those questions and you can share your answer and solution with me at teacher@testprepadda.com. Now you can see this is question number 1. This is question number 2. This is question number 3. This is question number 4. This is question number 5. Now I will talk about this question number 1. This question says pK value of cycloheptatriene is 39 but of cyclopentadiene is 16. Explain. So when it says pKa value, that pKa value is actually defined for acid. That means you have to compare the acidic properties of these two given compounds. As per conjugate acid base theory, more the basic strength of conjugate base, less is the acidic strength of parent acid. So if I try to write the conjugate base of these acids, first of all, the structure of cycloheptatriene, the structure is like this. Double bond here, double bond here, double bond here. You can say 2 hydrogen atoms are attached here. If I write the conjugate base of this compound, then it will look like this. Double bond here, double bond here, double bond here, and negative charge with the lone pair. Similarly, cyclopentadiene. For this, if I write this structure, it is this. This is cyclopentadiene. And if I write the conjugate base of this, I will remove the acidic hydrogen from here. Negative charge lone pair will come like this. So this is the conjugate base of cyclopentadiene and this is the conjugate base of cycloheptatriene. Now we have to compare the basic strength of the two. Now we have to compare the basic strength of the two. Basic strength is related with the electron density of these two carbon atoms, and electron density can be decreased or increased by different factors. Here what is happening, if this lone pair participates in the resonance with the ring, then what will happen, total pi electrons inside the ring will become 8 pi, 2 2 2 and 2, 8 pi, and that indicates what, anti-aromaticity, and this will destabilize the system. If the conjugate base is less stable, its parent will be less acidic. So here the same thing is happening. Now here what is happening, if the lone pair participates in the resonance with the ring, total pi electrons inside will be 6 pi electrons. So 6 pi electrons means it obeys Hugger rule here. So this compound will become aromatic. This conjugate base becomes aromatic, and that is why extra stable. If the conjugate base is stable, its parent will be more acidic. My point is clear. So in this case, the lone pair will not participate in the resonance with the ring. Otherwise, the compound will become anti-aromatic. So this is highly basic in nature. So its parent will be weak acid. While here the lone pair participates in the resonance with the ring, and this way it becomes aromatic. That is why the electron density here will be very less. Conjugate base will be very weak. That is why its parent will be highly acidic in nature, and this you can see in the values of pKa. Low pKa implies more acidic. My point is clear. Now I will take another question number 2 here. Here question says, which of the following compounds are anti-aromatic? Anti-aromatic, and we know for anti-aromaticity there should be a ring should be planar, there should be a resonance, and a loop of how many pi electrons? 4 and pi electrons. A loop of 4 and pi electrons. Very special. Now, in this case, what is happening? This carbon is sp2 hybridized, this carbon is sp2 hybridized, this carbon is sp2 hybridized, this carbon is sp2 hybridized. All are double bond carbon atoms. Here also, this carbon is actually attached with this carbon, and one hydrogen atom. 3 sigma bond means sp2 hybridized. So overall ring is planar, and resonance is there, plus single double, plus in conjugation with double, and that is why resonance will be there. And how many pi electrons are involved in the ring? 2 to 4 pi electrons are involved, and that is why it is what? Anti-aromatic. This is anti-aromatic. Now look at this one. Here what is happening? All carbon atoms are sp2 hybridized. If the lone pair of this carbon participates in the resonance with the ring, and in that situation what will happen? Total number of pi electrons in the resonance will become 4 pi. My point is clear. 4 pi electrons means again it will become what? Anti-aromatic. Anti-aromatic. In this case, what is happening? Resonance is there. Each carbon atom is sp2 hybridized, and that is why planar ring. Ring is planar. Resonance is there. And how many pi electrons are involved in the conjugation? 2 pi electrons, and that is why it obeys Huckel's rule, and compound will be, this ion will be aromatic. In this case, what is happening? Interruption is at this point. The ring does not involve complete delocalization. That is why this is non-aromatic compound. My point is clear. So first is anti-aromatic, second is anti-aromatic, third is aromatic, fourth is non-aromatic. Now in the same manner, other questions of this exercise can be attempted. You can share your answer with me at teacher@testprepadda.com. Thank you. This video is presented to you by www.testprepadda.com. TestPrepAdda.com provides free audio-visual lectures of different subjects by expert faculties, free online tests prepared by expert faculties to students who are preparing for engineering or medical entrance exams or planning to take exams like KVPY, Olympiad, etc. It provides a platform where students can interact with mentors to improve their performance in the exams. The mission of this online medium is to help students to achieve their goals. Log on to www.testprepadda.com to watch free video lectures on different topics, to download free revision notes, to take free chapter-wise online tests, progressive test, and mock test, to discuss doubts with mentors. Thank you for watching the video. To stay up to date with the latest videos, subscribe to our YouTube channel. Like us on our Facebook page, Test Prep Adda. All the best.